The broadcast is now starting. All attendees are in listen-only mode.
All right. Would like to welcome everyone back to another KevCAM night class tonight. Tonight have Tim Carl helping out with any questions come along the way. Tim, you with us?
I'm here.
Perfect. And as well as Greg Payton to make sure we're hitting all our points and making sure I'm not missing anything for you guys. So Greg, you with us?
Good evening, everybody.
And let's see, last week, Greg, where were you located?
Last week I was out in Phoenix, Arizona.
And where are you now?
Now I am in Anaheim, California.
Oh, man. So it's funny that you say that because for those of you guys that are interested in doing on-site training, either you'll probably get myself or Greg Payton come on out. So if you guys are interested in it, let your account manager know. But all right, I'll stop the babbling here and we will get into the night class for everyone. And what we are going to be covering tonight is HSS Constant Z. Now, there is a lot of stuff inside of HSS, and it may look a little overwhelming. And over the next probably 6 to 8 weeks, I hopefully will turn it from looking overwhelming to very easy to use for you guys. So, all right. So what we got a couple different parts here, and we'll go over the linear, constant Z, and hatch. But for, like I said, tonight we are just going to mainly focus on constant Z, going through the ins and outs of it. So to get the ball rolling here, go ahead and open up our HSS. Now, for those of you guys that are looking at this and you hit this little drop down right here, and all that you're seeing is linear and constant Z, that means that you guys have HSS Limited. And with Limited, you're only going to get 2 different toolpath options right here, as well as you won't be able to do some of the gouge checking, as well as doing some of the spiral features. So there are some features that are locked out. And if you guys want to see all these options in there, let your account manager know, and then we can get those added in there for you. But like I said, it is a very limited version of it. You can do 3D work in there, but what I'm going to be showing you guys is the full version going forward, just because I can't get a license for limited being an employee here. So starting at the top, coordinate system, basically what MAC position are we wanting to work on, or MAC or position that we're working on. Now, geometry. Now, as we kind of start going through this, like I said, it may look a little confusing, but if we go through it with a fine-tooth comb, which I'm hoping to do for you guys, it will make a lot more sense. So drive surface. Think of the drive surface as the surface that you guys would like to cut. So the area that I want to cut is these faces right here. Now, you may be looking at this and saying, well, why do I have to select each individual face? Well, what's happening is HSS uses the actual surface NURB of the model, where if we go off of 3D iMachining or HSM, HSR, it goes based off of a faceted model. So that's the reason why we need to go through and select each individual surface, is because each surface can actually have a different vector direction as well. And what I mean by that is by going here and click the show direction, what it will do is it will populate little arrows showing you where that surface vector is going. Now, if you guys are running a cut along here and all of a sudden your toolpath dives way deep into here, this is one of the things you would like to check first. And it's all dependent on how the surface was created for you guys, that we may have a reversed one in here. So if you guys do run across, if there is an arrow that is going in the wrong direction, you can just simply right click on it and do reverse, or you can do reverse all. So now, why would I use constant Z? So constant Z is constantly stepping down in the Z axis. So where constant Z really shines is your tapered walls, or like right here, that go from 45 degrees to 90 degrees. So a more of a steeper angle walls. Now, once we get into a flat area, since we're stepping down in a constant Z, you'll see we won't get a nice of a surface finish in there because it's based off of a constant Z variable that we're telling it to step down versus a step over. And we'll talk about the step over next week when we cover linear, but in the constant Z, we are just constantly stepping down. So in the area type, have a couple different options here. Full avoid at the exact surface edges. Now this is going to be on by default, and a lot of the stuff that is in here by default is, I'm not going to say always good, but most of the time there's a lot of stuff that we don't really have to touch in here unless we really want to get in there and fine tune some things. So maybe if our tool path isn't going right to the exact surface edge, then we can come in here and do full start at the exact surface edges. And this dialog down here will kind of show what we're looking for. So we want that tool path to start right at the exact surface edges, where up here we're starting just a little bit off based off of the tool that we're using or the tool contact point. Okay. Now, stepping down here, we can create a boundary. So what this boundary will do is, maybe we just want to focus on a specific area. What you guys can do is throw a 2D sketch on there and keep it contained. Like if we were do a normal 2 view here, let's say we just wanted to keep it contained to a circle area, we could draw a sketch on there and it would trim off the tool path outside of that circle for you. So, and then drive surface offset is basically maybe if we want to come in here and do a semi-finish, we could come in here and do a drive surface offset and offset that tool out off of the surface by a certain value. Or maybe we're taking this cut here, we went and ran it on the machine and we need to go a little bit deeper, we can put a negative value in here as well. Tool. We're just gonna go ahead and grab a ball and mill here. Now, the tools that HSS supports are all right here. So HSS will support a end mill, a bowl, ball, face, dovetail cutter, taper mill, taper ball mill, slot, lollipop, and all your barrel cutters, as well as your lens cutters right here. So definitely, those are the cutters that HSS supports for you guys. Okay, so we got our tool. Now our levels is basically just our clearance. What is our clearance areas? Now, if you guys are looking at, well, I just want it to go down to a specific depth and stop, then we want to set up a gouge check at that point. But your levels page where we have covered in the past of, your upper level, lower level is now the levels inside your HSS is going to be just your clearance. Now, by default, this will be set to automatic. Now, if the clearances aren't good, you can definitely go back to the older way, which is plane or cylinder. For those of you guys are running 2019 or older, you won't see automatic in here, a new feature that they added in. So in the plane, we have what direction we want to go to, how high we want to go up, and all that. Toolpath parameters. Now, in here is basically, think of it as how nice of a finish are we looking for. Now, how I do HSS and 5-axis, and for those that have been in the night class for a while, HSS and 5-axis are the exact same operation. The only difference is the tool axis control that is added in here in 5-axis. So think of this as a building block. So we got our geometry, we got our tool. At that point, I like to do a save and calculate. I like to see what kind of tool path I'm putting on there. So right here, we have a cut tolerance of 8/10. If we need to turn that down to a smaller tolerance, the only time I've kind of run across that is if we're working in kind of a tight area, we can turn that down a little bit. And you guys can make that number whatever you like. But what I like to do here is keep your step over large. So right now, I can see all my tool path that is going on back and forth. If I come in here and make this really fine right away, one, it's going to take a little bit more time to calculate, but two, it is really tough to see what that tool path is doing right now unless I zoom way in. So one thing to kind of keep in mind is keep your step over large until the very last thing that you do. And I'll even play this through in HostCAD and Solid Verify just to verify that my tool path is what I'm looking for. Now, the step over is going to also indicate what surface finish you're looking for. So there is a calculation that goes, and maybe Greg, you can help me out here, but with the step over, we will get a scallop of 5 thou. So what that means is, for those of you guys that have a, trying to think, the surface finish, RA call out, can't think of the name of the instrument that they use, profilometer. For those of you guys that are using a profilometer, and on a blueprint, you guys have a call out of, 32 RA finish. Well, right now we have a 521 RA finish. So, like I said, this is a very large step over. If we are trying to achieve that 32 RA, we need to kick that down until we see 3/10 2 millionths of a scallop here. Okay. Chaining tolerance, something that we really don't have to mess with a lot. Like I said, kind of our default is definitely good right here, but maybe as we're going over a curvature surface, we're not hitting all the areas, especially in a smaller area. So we can turn down our chaining tolerance right there. You can kind of see it's just adding more points in there for you guys. Now, sorting, how do we want to cut this? So right now we are doing a zigzag pattern. So it's starting at the top, coming over, coming up, and then coming down and doing a zigzag going back and forth. For those of you guys that are running limited, you will just get one way or a zigzag. One additional one that you will get when you guys get the full version is spiral. And I'll show you a part when we can really utilize that spiral in there, but you guys do have the option to change up your pattern. Maybe you just want to do one way just because the cutter, you do have that option there. Now your cut order is, you do have some options. Do we want to start from the center away, from outside to center? To be honest with you, since I've been using this since 2006, that is one that I will hardly ever touch. Now, machine by lanes or regions. So what this will do is, if we're trying to do multiple parts or multiple surfaces and there is a gap there, if I tell it to do it by lanes, it's going to kind of skip over and try to do it all as one. Where if I would like to focus it on one specific part and then have it go over there, then we could switch it over to regions and it would keep it contained per region for you guys. So, as well as the flip step over, maybe I wanted to start at the bottom down over here and work its way up. At that point, I could just do flip step over, and we're going to do the exact opposite. So it's going to start down here in the corner and work its way up. Now you guys can give it a start point as well. In the modify, a lot of ones over here that you don't really have to touch at all. But one that does come up every once in a while is the 3D tool compensation. So if you guys are looking to do a little bit of 3D comp and your machine supports that, here's where you can turn it on. Rounded corners on our tool path, so we can go on there, and so we're not getting sharp corners, but I'm actually going to show a different way of getting rid of these lift up and lift downs, as well as these sharp corners that are coming in there. We can set up an angle range, so if we want to keep it contained to a specific area, like we said, the constant Z works better from that 45 degrees up to 90 degrees, so we can keep it contained to that region. The extend trim is one that will be used quite often. And for those that have run across it in HSM, what HSS will do is it will actually take the surface and keep going up versus coming up and then doing a direct cut over, or if we're trying to extend the surface over here, the tool will not drop down in Z following the part. It will go based off a theoretical surface that is being added in there for you guys. So we can do a extend trim to extend it or trim it. You guys can do it off a percentage of the tool, or you guys can type in a diameter in here.
Now, Kevin, can you just populate those boxes, and that way we can see the tool update in real time? That way our viewers have a idea of what those changes are doing.
So let's do something big. So we'll do 100% of the tool. So I'll just do the start and end first. So what we're doing here is the start of the tool path over here has been generated farther out, as well as the end of the tool path over here. Now, if we do a side extension, which we want to extend up towards the top as well as the bottom here, we can do just do 100%. And now you can see that tool path does carry out farther past. And what you're seeing right now is the tool path based off of the center of the ball. So the center of the ball basically is what's happening over here is we're cutting the air. But this does come in handy when you're trying to blend together two surfaces, or just making sure that we get the entirety of that part. So let's just go ahead and turn that off right now. Now, tool control. In here, we can shift our tool path up or down by going in here. So this one will get more relevant as we get into more of the 5-axis side of things, but we will cover this a little bit more as we get into the more complex of the technologies that HSS offers. But we can basically shift the tool path down or up in either direction right here, kind of like the drive surface offset. But like I said, we'll cover more into that in future video here. But the tool contact point is a very helpful thing in here. So right now I have set it, or it's set by automatic, and that's the one you're probably going to use 90% of the time. But if you did want to customize it, we can do at center, at radius, at front, and some of the operations you will actually have a user defined based off of the tool that we're using. We can shift it over in I'm trying to think. So if we're looking at the coordinate system, we can shift it over in the left or the right, as well as the y-axis up or down. So if we want to more on a certain point of that tool, we can shift it over at that with the user defined. But since we are using just simple HSS along with constant Z, we can leave it right at center. Now, a big one that you will constantly be using in here is the link section. So the link is just like in a profile. Do we want to use it a lead in or a lead out? But inside of the link section, we have what's called links. And every time we go from one tool path and it comes up and goes over, that is a link in there. All these red lines are links. So what we're telling it is if we have any gaps along the cuts, it's going to do a direct move for small gaps, and for any large gaps, it will go up to the clearance. So what I mean by gap is if we had a hole in here and we wanted just the tool path to skip over the hole, and we didn't want to go into SolidWorks and do a fill hole in there, we could just tell it to do a direct move right over. Now, the links between the slices, so each one of these lines right here, it's coming up here, we could, it's going up to the clearance area. So small moves are staying down, it's doing a direct move in there, and we can actually see that with one of the tool paths right here, it's just doing a direct move in there. But there's no point in coming all the way up in this particular part, no point coming all the way up to the clearance. So what I like to do in here is, we have a lot of different features in here, but my personal favorite in here is the blend spline. So now if we go ahead and save and calculate, what the blend spline is going to do is it's going to do a nice arc working its way out. versus doing that straight line movement where we get some jerkiness in the machine. We're doing a nice blend, going from one tool path transitioning into another tool path. Now, if we go down a little bit farther here, we can see one that is set up as a direct. So what we can do at this point is tell it to do a blend spline as well. And now we got nice smooth tool path going through there, and you will not get any of that machine jerkiness going on there because we're not coming to an exact, we're doing an exact X movement and then doing a sharp Y movement. We're doing a nice arc working its way around it. Okay. So that one is a big one. And for each one of these, we can tell it between the passes, we can tell it to do a different lead in or lead out for the small gaps versus large gaps, as well as down here. Now,
Kevin?
Yeah.
Before we move on too far, I was going to say, can we go back to the approach and retract? Because there's a lot more robust options here than we'd normally see with the profile or pocket style tool path.
Yep.
So maybe you can demonstrate those and show everybody what each one does.
Absolutely. So the first entry we can use, you do have a couple different options right here. But I think the one that Greg's talking about is use lead in. Well, right here, what kind of lead in am I using? So there's two ways to get to this point. We can hit the little browse button right here, and this will bring in basically our default. And if we're not wanting to do an automatic arc, you guys have a ton of different options here. To me, these get a little bit confusing at times. So if you call me up on a tech support line and ask, basically I'm going to go through here and just kind of click, just because the way of the curvature of the surface, orthogonal angle, usually means 90 degrees off of that surface. But if that surface is going in one direction and I think it should go in a different direction, you have a lot of different options in here. Or if you want to do lead in and not have to hit that button, they do have a separate tab for the default lead in, lead out. So same options right here for you guys. So we have a tangential arc, reverse tangential arc, vertical tangent arc, and I'm not going to read through all these because it'll put you guys to sleep, but there's a lot of different options in here, and for each one of these options, if we're doing a tangential arc, I have control over the sweep angle, as well as how large that we want to go. I can tell it a height in here, as well as a feed rate. So maybe as I'm arcing into this material, I want to lower the feed rate down to maybe 50% because we're approaching into the material. If we go to like an orthogonal, we're doing an arc coming in there, and let's just do a, let me go back to link and turn it. Oh, yep, we do have it on. And we'll turn in our lead off here. And the reason why it's messed me up is I got used to the toolpath being up here. So right here, we can see that we're doing our tangential arc or orthogonal arc in there. Let's just see if we can calculate. So maybe we would like to do a vertical tangent arc. So now we're coming in doing a straight drop, doing a nice arc into the material at that point right there. Like I said, this is a great point to come in here and, maybe you want that feed rate to be slow as it's arcing into the material. Maybe our stock is a little bit oversized or coming off a saw cut. We might have a plus or minus 25 thou there, so our stock might be a little bit thicker than what we're assuming for. So this is a great way to slow down and then come into the material. Like I said, we could go through all these right here and show you what each one does, but it's all dependent off of the surface as well. So, if we do a vertical tangent arc right now, maybe on a different surface, it may look just a little bit different. Hopefully that makes sense. Is that making sense, Greg?
In most cases, it's going to look the same as what you're seeing here. If you get some extreme curvatures, essentially you're going towards the normal of the surface. So As long as you know that the point it's going to hit, it's going to be normal to that surface
Yep.
direction. Then it's once you get an idea of what each one of them is capable of doing, it's easy to get repeatability.
Yep.
With those selections.
And one thing, Greg and I stress this all the time, is once you get something comfortable in here that you like, you like seeing the tool path, everything set up, save it out as a template so you guys don't have to go through and reset up any of this stuff again. For myself, the first thing a lot of times what I'm doing is I'm coming to the link section and I'm switching these over to a blend spline, and there, because 90% of my tool path, that's what I'm having to come on there and do. So like I said, save that as a template and put that as your default if it's something that you use all the time. So when you go to load up this HSS operation, it's already set up for you guys. So now, gouge check. HSS and simultaneous 5-axis, as well as some of the new turbo 3D HSM and turbo 3D HSR, you will have the option for gouge check. HSS will gouge your surface. One, because if we tell it to gouge it with our drive surface offset in there, it will come in there and gouge in there. But as it's coming into, maybe a blend area, it will overcut, and just because it's going off of the surface, it's going to try to keep following that surface, even though that doesn't exist. It's going to, with that theoretical area, you will get some gouging going on in there. Now, typically on a part like this, we don't have to worry about it, but you coming in here, what does a gouge check do? So basically, by enabling this, we can tell it, and I'm going to turn off our check surfaces here. I'm telling it not to gouge the drive surface, to check the gouge against my tool shaft as well as my tool tip. And if you're worried about your arbor or your holder, you can turn that on as well. And when it comes to a point where it's going to gouge that drive surface, what do we want it to do is basically what it's asking here. So do we want to retract the tool? We can do a trim and relink, which is one that I use quite a bit. We can stop the tool path calculation, as well as do a report so we can kind of see what's going on with that gouge right there. Now, what I like to do in here is if I'm worried about a surface that I'm going to be hitting, I will also set up a check surfaces. Now, you can do the check surfaces and the drive surface all in one area, but one thing that you cannot do is let me reverse a little bit. The check surfaces are the surface that you do not want the tool path to touch. So in this particular case, I do not want it to touch the top, and I don't want to touch the front as well as the sides. So I can go in there and tell it that we give it a check surface and not to touch it. The one thing I do like is if I keep these independent, so right now I have it set to when we hit if we gouge our drive surface to retract the tool, but if I come in here and do a check surfaces, I can tell it to do a trim and relink, as well as I can tell it how much stock to leave up there. So our check surface, like I said, is the surfaces we don't want it to touch. Now I can individually click all these surfaces that I don't want to touch, or I can just click on all adjacent faces and it will pick all the surfaces that are adjacent to that surface there. And now I can tell it that, well, I don't want that tool to come in contact with that surface, and I can tell it that I would like to leave, 5 thou on there, or, you can put whatever value that you would like in there, as well as you can have a separate strategy. And you guys can come in here and add up to 4 gouges in there. So maybe up here I wanted to leave, 5 thou, and maybe on these sides I wanted to leave 3 thou, and maybe on the front I wanted to leave 2 thou. You do have that option in there. Okay. So that is gouge check. Now you do have a clearance in here, and basically with our clearance, we can set it up to go with our holder. So I want to keep it 100 thou away from the holder, 25 thou away from the arbor, and then rate up the size on the tool shaft as well as the angularity. This one, don't use a whole lot with HSS. This will get used more in the 5-axis side, but that option is there for you guys. Now in the advanced area, oh, good.
I'd say if you're doing any kind of like deep cavity molds or something like that, it would really come in handy.
I think of a deep cavity mold. Yeah, that's very true. I just think of deep cavity mold, it'd be HSM, but yeah, you're right, because we got some finished areas that we need to touch up or in there or something like that left over. So air moves in the safety distance. So basically it will be any air moves will be clearing by the 400 thou. In the advanced, to be honest with you, I've never touched anything in here. Greg, have you?
Typically you don't need to. However, it's nice to have these. Like you see a lot of it is reporting, letting you know that if the tool is going to gouge, you're going to get a notification about it instead of relying on the simulation to show the gouge, or worst case scenario, finding it on your part because you didn't do simulation.
Yep.
The extend tool to infinity I've used in the past, just because you'll get into situations where the tool definition is a little bit short. And so if you have something that is on a bit of an overhang, if that tool is not defined tall enough, you could run into a potential gouge. But by checking the extend tool to infinity, it eliminates that. So there are good options in here. It's just the circumstances are going to be rare. But they are nice to have.
Now, roughing and more. Don't think of this as quite roughing and more. There's a lot of different options in here. If we are doing a rough cut on here, we can do multi-passes, which is kind of do like a clear offset in profile. So we're stepping out that geometry, as well as depth cuts. Now, some of these features will be grayed out if you guys are using just Express, but depth cuts, stepping down in the material, doing a translate or rotate. Before, you were not able to come over here and do a transformation. You have to do it in here. So this is just another area to come and do your translate or rotate. Stock definition is one that I do like if I am doing some roughing strategies. Well, let's just do it real quick. So we want 10 roughing passes at 0.1. Okay. All right, so we can see our roughing passes. And since we have this part already roughed out, we're going to be cutting a lot of air in this particular scenario. What you can do in here is come into your stock definition and tell it to avoid any air cuts following along the updated stock. So now if I come in here, it's going to look at my stock, what I have left over, as well as my HSS path, and it's going to trim any path that is that would be cutting any air at that point. So you can kind of see it trimmed it off, and we have no more step downs in there. So that functionality does come in handy, because when we do multi-passes or depth cuts, it's just projecting it out and it doesn't see the surface. So now we're telling it to trim it, so we're not doing any air cutting in there. And as well as our links between passes for that area right there. So we can see we do have some jump ups in there. So let's go ahead and turn that off. And multi-passes, we'll turn that off. All right, so that is everything inside of HSS. So let's go ahead and save and calculate. Now, like I said before, come in here, get your toolpath looking the way that you want it. The very last thing that I would like to see you guys do is come back and change up your toolpath parameters for your surface quality. So let's go ahead and play this through here. Got to give it a second because we really messed up with the stock from all the stuff we did. So we're just going to give it a second here to update that stock for us. Cue the music. Greg, that was your hint. You got to start singing. Oh wait, no, that was his job, right?
Yeah, Tim drew the short straw on that one. My song and dance is when we want everybody to leave.
Yeah.
What did I win?
We're waiting for you to pull out the banjo so you can start playing our elevator music while we're waiting.
I don't have any banjos. I got a ukulele.
There you go. That'll work. All right. Good thing it pulled up because we don't have to worry about your ukulele. All right. So let's go ahead and play this through here. And as you can see, we have a very rough finish in there. So like I said, last thing we're going to do in there is now I want a RA finish of something pretty nice. So this is going to give us a 20 RA finish if I put a maximum step over in there of the constant Z area. And it's kind of a little tough to explain, but so you can see in our constant Z, we're constantly stepping down that 10 thou. So we're going to get a real nice finish in there. But as we get into the flat area, not totally flat, but I think this is drawn to like 25 degrees right here. We're not going to get as nice of a surface finish in there due to it is set up to just do constant Z step down versus step over. And we'll cover the step over next week, but we hop into our solid verify here, play it through, and get that nice, beautiful finish in there. But like I said, this area up here where we have more of aggressive angle, we're going to get a nicer finish versus down over here based off of a constant Z step down. So, okay. Any questions on this part? I know we're going a little bit long, but just want to make sure we don't have any questions coming out of this one, or I'm not even give Greg the opportunity to jump in yet. All right, grab another part here. And like I said, there's a lot of options in HSS, but for the majority of it, and that's what I want to show you guys on this part, is you don't have to choose every little checkbox. You don't have to go through all that unless you need to. So right here, we have a part, kind of a mold cavity that I'm eating my words that we were talking about, a deep mold there. Great.
It's only too perfect.
Yeah. All right. So what I am looking for, and I like to think of HSS is you really want that perfect surface finish in there. You're going to want to use HSS. HSM will do a great job, but you will have you won't get as nice of a job with HSS based off of the surface NURB versus HSM using a faceted model. So I said I was going to stop blabbling. Come on. All right, so we got our parallel cuts constant Z. Now it will remember what you last left off. So if you're coming in here and constantly doing morph between boundary curves, when you start a new iMachine, when you're starting a new HSS operation, it will remember the last one that you chose. So our geometry, areas that we want to cut, right here, and we can actually grab this little radius down here. You can see GoToMeeting loves to tack my video card. got them all. All right, so we're gonna grab our tool. And we'll go ahead and use our ball end mill. Levels set to automatic. Like I said, we'll leave this on a step over of the default 50. Come in here and save and calculate. Let's see what our toolpath is doing first. So now that I have it in here, oh man, my computer's just slowing down. Well, I forgot to grab those surfaces. Geometry, edit. Okay. Save and calculate now. Okay. So now we got our toolpath, basically what we're looking for, but I don't like how it's coming down, doing a lap, going all the way around, and then coming down at an angular area and then taking another cut. So to clean up that path, we can go to our sorting and tell it to go from zigzag to spiral. Save and calculate. Now we are doing a nice spiral cut, doing one entry and one exit. So I get a little side view here, doing our laps all the way around in a corkscrew pattern. So I really like the way that looks. I don't have to worry about any links at this point because I don't have any gaps. We're in a constant surface all the way around. Let's go ahead and see what this is going to look like in Solid Verify. Play this through. All right, looks good. Now, we talked about gouging. This is one thing that you will want to use quite a bit with your HSS to make sure we're not gouging or leaving material, which is our stock target comparison. And I can see that I'm gouging pretty heavily down at that bottom. So what we'll do is go to our gouge check and we'll enable our drive and I'll uncheck our surfaces, as well as in our gouge 2, I'll turn on our check surfaces and I'll go ahead and grab those all adjacent faces. And I'm going to tell it to, we can tell it to retract tool. Save and calculate. Now, when we go ahead and play this through, and one thing to really, it's not a mandatory thing at all, but one thing I really like to do is think of HSS as a building block. Don't, if you're trying to go through and figure out why is it gouging, don't go and change 10 different things in there. Do one at a time. That way you can kind of see what it's doing to affect that toolpath there. And one thing that I've learned just on the tech support side, I'm sure Greg has as well, is if there's something in there just not making sense at all of what it's doing or anything like that, start fresh, because there may be one checkbox in there that's throwing you completely off. So now we'll go and do our execute, and now we are not gouging against that floor like we were before. And see, we got nice clean toolpath going all the way around. Now, like I said, last thing that we want to do is get our surface finish. So now
real quick, Kevin.
Yeah.
Before we jump into the actual cleaning up the surface finish, let's go back to the gouge check, because this is actually a really good example of what's going on with the strategy there. Because you can see that you told it to retract the tool, so it makes another lap down there at the bottom, but it kind of picks it up off that floor in Z. I don't know if maybe you can zoom in there
Yep.
and show that. So, I mean, in those corners, you can kind of see what looks like overlapping lines where it's actually picking up that tool in Z and making another lap around. Can you change the strategy to trim and relink?
Absolutely.
And we'll do another save and calculate and see what happens to those passes.
So
It
now,
looks like we got rid of one of them, right?
yep. Now we just got two smaller areas there.
Where it's stopping the toolpath calculation, basically
Up.
trimming out those passes where it knows that surface is going to hit.
Yep.
So just looking at some of these options here, you can see an appreciable difference in what the gouge check strategy is going to do.
Now what we can do too is, let's say we wanted to leave maybe 5/10 on there. Now, what this should do is, oh, we still have the same pickups. So I was thinking it might eliminate some of that pickups in there. Well, let's just try something a little bit bigger here. Let's do 1,000. Nope. So we can tell it to leave, when we go to do that strategy right there, that we're going to leave 1,000 of stock on there, and then we can come back with a different toolpath to clean that up at that point if you wanted to as well. But
which in this particular instance, if you needed that radius to be true the size, you'd probably have to go back in and clean it up with a smaller ball end mill.
Absolutely. And I mean, I didn't go through all these in here, but there's a lot of different ones we can do along the Z-axis, different planes, but by default, we can just do tool axis plane, which is going to be straight up in this case. So now if we just do retract tool, we'll get that nice clean tool path, keeping that tool down inside of there. But like Greg said, it will just do a little bit of an air cut, keeping that tool down in there. So now, so now if we go to our toolpath parameters and tell it that, we want a nice good finish in there, we can do like a 15 thou, which is going to give us a 22 RA finish in there. And don't base your scallop off of, all right, I know for a fact that I'm going to get a 22. What that is it's, RA is a math equation that's figured off of from cusp to valley, or from peak to valley in there. And that's not taking into factor machine rigidity, tool balance, or anything like that. So if you guys are trying to achieve a 32, kind of like when we talked about iMachining, that's where we can get that. So if we go and simulate this now.
And there is a question in there, Kevin. Duncan wants to know why you put the check surfaces in gouge 2 rather than doing it all in one.
Okay. Yep. I'm gonna show that for you guys. So now we put our 15 thou step down in there, and we're going to get a real nice surface finish going in there. So reason why we're going that I like to keep them separate is with the gouge check, if I do my check surfaces in here, I'm stuck to doing, anytime we have a gouge on my drive surface, I'm going to do a retract tool, as well as a check surface, I'm going to do a retract tool, as well as I don't have the option in here to do a stock leave in there, where if I keep them separate for a gouge 1 for my drive and a gouge 2 for my check, now I can do a different strategy in here. And when it comes to a check surface, I can tell it to stop the toolpath calculation and to leave 1 thou there. So that's why I like to do them in separate, because you get a little bit more control there. Now, if we're just doing off the same one, definitely you can do it all within gouge 1. And I don't remember which one mine was, so I can just hit this little browse button right here and find, yep, that's the one, because it's covering the top and the bottom. and we can do it in that case right there. So when your strategy is the same for your check surface as well as your drive surface, you can definitely keep them all in one. Just remember that you will not be able to do the stock leave option on your check surfaces. So does that help out, Duncan? All good, perfect. All right, well that's, I know we went a little late today, but there's a lot inside HSS, and like I said, over the next umpteen weeks, we're going to go through a lot of this. For those that are going to watch the entire series, some of them might be repeat because we're going to go over the gouge check as well as the rest of it in here. We won't go as fine of a detail, but each week we'll be going through a new technology in here. So next week we'll be covering constant Z, and then heading to hatch, and then my favorite, which is parallel to curve, as well as parallel to surface, all these different options in here for you guys as well. So we will be covering a lot of HSS and probably get bored with it, but there's a lot in there that I want to show you guys. So anything else that I'm forgetting, Greg?
The only thing that I had wanted to see, and it could be covered in subsequent classes, is more along the geometry options, the limit by points under the area type.
Yep.
I think this one would probably be a pretty good example for it.
Yeah, so in here, we can do, so we kind of covered the full start and exact area, but by different points is kind of keeping it contained to a specific area. So what I mean by that is up here, let's say I wanted to start right there, and I want it, so since this is an entire surface, it's going to go all the way down, but if I want to keep it contained to maybe that level right there, okay, what it will do is it will keep the toolpath contained to that area, which is does help for maybe you know, we don't have to set up a check surface in here and raise that way up. We can keep it contained to a specific area. The nice thing about this is you guys can create sketch points in there, and you can dimension those sketch points so we have an exact tool path that goes to that exact location. Now, one thing to kind of remember in here is if we're doing parallel cuts, constant Z, or linear, we will only get these three options in here. But if we pop this over to morph between boundary curves, and we'll get over this on a later time, but you'll see that we have also determined by number of cuts in there. So we can tell it, if we're just coming down here and we have a ball end mill that's that exact size, or a bull nose, we can click that surface, and instead of trying it to go through and do multiple laps, we can tell it just to do one lap around there, and it would do that as well. But we'll cover that in later classes. Does that hit it good, Greg?
Yep. Yeah, I just you had brought up the limiting depth by check surface earlier, so I wanted to make sure that this option was shown. Yep,
forgot about that one. So yeah, it's a great one to have. Like I said, it's kind of works along the lines of, you know, your 2D boundary, keeping it contained to a specific area, but this keeps it contained in the, I guess, by points versus having to sketch physical geometry in there as well. So.
Okay, we do have another question in there about where you can find the previously recorded classes. And hopefully ordered by date.
Absolutely. So if you guys, we'll kind of wrap up the constant Z for tonight. And for those of you that are looking for previous videos, you can, on the website, let's just go back to the home page here and find SolidCAM. So on our home page, and you want to make sure you have the American flag up there, if you hover over webinars and go to the night class where you registered, you can click where it says missed the last class. You can click there, and it will bring you right over to the SolidCAM University channel. Now, all these classes are ordered by date. So if we go to videos, we can see last week we did a 3D eye machining. Week before that we did doing a master file. Now you will see some shorter videos in here that Mark does a great job on, just kind of getting right to the specifics. So doing a default CAD coordinate system, or changing max, some quick helpful videos in there. If you are looking for a specific video, definitely hit the search right here, and anything that you're looking for, related to, in this case, HSS, it will bring up all the videos that we have to do with HSS. So we actually covered the HSS parallel cuts, linear, constant Z, and hatch. Greg and I did it 3 years ago. It doesn't seem like that long ago, but so there is a whole night class on that from 3 years ago. We don't delete any videos on here. Here's one that Mark did about a year ago, just doing HSS full. There's a whole different slew on there, as well as playlists in here for these specific classes. So maybe if you're looking for a specific area, we can see the what's new in there. Maybe you want to see some, live cuts, some on simultaneous, simulation or simultaneous, all that stuff in there, you guys will see as well. So definitely check out the playlist in there. But hopefully that answers the question. But all right, well, with that being said, do we have any other questions before we wrap it up for the night?
No, I think that is all that is coming in from the chat area. Perfect. And that's all I had for the evening, so I'll let you off the hook easy.
Yeah, I was gonna say, I was getting a little worried there at the end of, well, like to see, kidding.
Yeah, all this traveling's got me off my game.
Yeah.
I'll have to study hard and get you next time.
Yeah. All right, everyone. Well, I just want to thank everyone for joining the night class. Hopefully you guys got something out of it tonight. Any questions or concerns that do come along the way, definitely send those over to us or myself via email. For those of you guys that are watching on YouTube, my email is in the description below for you guys. So let us know what we can do to help you guys out. All right. Have a great night, everyone.
Good evening.